My name is Darren Nattinger, as Jeremy mentioned. I just had my 25-year anniversary at NI back in January. So I've worked there for, thank you. I've worked there for a quarter century, and that's how long I've been in the LabVIEW community, and I've decided I'm sick and tired of you guys pronouncing my last name incorrectly. So today, you're going to learn how to pronounce Nattinger. Grr, like a tiger, like Tony the Tiger, like Frosted Flakes. They're great. That's how you pronounce my last name. If you can't remember that, it's also like the G in GIF, okay? So now, y'all have no excuse to forget. You have no excuse to forget. Fabiola, I've got 76 slides. I have no time for this. All right. Before I get started, all of my presentations are at dnet.org, including the one that you're watching right now. The short link for that is bit.ly/LabVIEW readability. I have a question for the room. How many of you guys work at a company that blocks bit.ly links? Anybody? See, like one. Okay, so I was considering like switching, but if it's just one guy and one other guy, I know I'm just going to keep using bit.ly. So, LabVIEW readability, that's where you can get these slides. They're available there right now. If you're in the back of the room, you could download them now and sort of follow along on your laptop so you don't have to look all the way up here. Yesterday, I spent about an hour moving all of the content of my slides up to the top of the half of the screen. So hopefully you'll still be able to see most everything, even though I'm walking around a lot. So, but yeah, you can download the slides. I also always include a link for Zoom It in my slides because it's an excellent tool while presenting. I'm actually not going to be using Zoom It any today, but it's normally a pretty good tool. All right, so I've got, as often happens with my presentations, I have quite a bit of lead up into the actual content of the presentation, and we're going to start that now. So, as Jeremy mentioned, I give a lot of presentations to the LabVIEW community. But most of the time, like when I come up with an idea for a presentation, there's a small number of catalysts for what guides me to create a presentation. The most common is what I call list buildup. So I start a list of things that like people ask me or questions that I answer, and I start a Google Doc and I just start, hey, maybe this will make a good presentation. And at some point there's enough stuff there that I just make a presentation out of it. Good example is 2 years ago when I gave the ludicrous ways to fix broken LabVIEW code presentation that Greg R. mentioned earlier. That was just after a couple of years working in tech support, coming up with a bunch of just crazy, wacky ways to fix busted LabVIEW code. I made a presentation out of it. Another category is something I call colleague enrichment, and that's when I find that there is a topic that the LabVIEW community knows a lot about that my colleagues at NI don't know that much about. I'll put together a presentation on that and deliver it to my colleagues at NI, and a lot of times that ends up being a presentation that I give to the whole community at large. Introduction to DQMH is a good example of that. I have given that presentation countless times over the past 2 years since I wrote it. I'm giving it on Friday at DQMH Day. That's an example of one that I wrote for my colleagues at NI originally, and now I give it to the LabVIEW community. And then another category I just call DNAT stuff, like stuff that kind of I'm associated with, like scripting or writing code fast, or the VI analyzer. I'll put together presentations on that. Today's presentation does not fit into any of those categories. Today's presentation was officially a new category. And that category is a passing comment that someone else made in a presentation that made me mad. I heard someone say something, and I got mad, and I said, I'm going to write a presentation about that. And that's exactly what happened. And in this case, that presentation is the Extreme LabVIEW Showdown that Hunter mentioned earlier, that he was a part of. I did not attend GDevCon in Europe in last September, but I did watch every single one of the videos. And when I watched this presentation, something in it made me mad. So at about the 15-minute mark, Hunter's up there, and he starts talking about class VIs and having class inputs and class outputs, and how you should not have a class that goes into a VI and doesn't do anything and comes out of the VI. That's something that I've talked about before. That's something I've talked about in my Brainless LabVIEW presentation. And Hunter actually included some diagrams from my presentation in his slide. And he also referenced that he pulled it out of my presentation. And here's how his quote starts. At about the 15-minute mark, he says, "These images are from Darren Nattinger's end of Brainless LabVIEW programming, where he's, of course, selected the brainless wire color," and then he giggles to himself, and some people in the audience giggle to themselves. This isn't even the part of the quote. I'm not there yet. I'm just halfway there. But I feel like I have to pause because, one, he said my name wrong. And two, I didn't even write those diagrams. I just grabbed them from someone else and put them in my presentation. So this is actually a good lesson for me. If I put code in a presentation, people are going to assume that I wrote it. So moving forward, if you see code in my presentations, I wrote it, or I'm going to tell you that somebody else wrote it. So,
I'm pretty sure I said Darren Cheeseburger.
You might have said Darren Cheeseburger, but no, you said Nattinger, I remember. Okay, but that's not the part that made me mad. The part that made me mad was right after this when he said, I will concede that the bottom approach of not passing unmodified class values out is the more technically correct, but at the expense of your code readability. Those are Hunter's words. I heard that and I paused the video and then I rewound to make sure I got it correct. So what was said was that this code, which I have written with a non-default class wire color, just for you, Hunter. Hunter said that this code is readable. This code is not readable. This code is pretty. This is pretty code. This looks nice. We, as LabVIEW programmers, our senses are calmed when we see the train tracks, right? It's pretty. But this code is readable. You can look at this block diagram and see which VIs are modifying the class. You cannot look at that top VI and see which VIs are modifying the class. You can look at that top VI and say, man, that's a pretty diagram, but you can't figure out what those VIs are doing. So I'm putting the bottom line on top, as people like to do in emails these days. I'm going to give you guys a summary of this entire presentation right now. The most important thing your code can be is functional. Nobody can argue with that. Your code has to work. That's the most important thing. Today I'm going to try to convince you guys that the second most important thing that your code can be is readable. Then there's a bunch of other things your code could be. It could be debuggable. It could be testable. Somewhere in that list is your code can be pretty. But that's lower than your code can be readable. Readability is the most important thing your code can be after being functional. And I would like for us to start talking about readability more than we talk about style. In the previous slide, I showed you a pretty diagram that was not very readable. As we go on in the presentation, I'm going to show you more pretty diagrams that are not readable and ways that we could be writing our code to be more readable. Now, what is readability? Readability is the attribute of your code by which you can understand its functionality and its behavior. Now, when you have readable code and a developer encounters your code, she is going to be as efficient as possible the more that the code is readable and she needs to augment the code or troubleshoot the code or refactor the code. Now, this developer could be any LabVIEW programmer. Oftentimes it is you, but it could be someone else encountering your code. In this presentation, I'm going to talk a lot about DevX. This is a term I learned from Fabiola. This is the experience of the LabVIEW programmer when they are developing LabVIEW code. So that's different from UX, when someone's using the LabVIEW program that you have written. This is the experience of the developer who's developing the LabVIEW code. So you might ask, isn't readability subjective? Like we're all human beings with our own thoughts and emotions. What's readable to one person might be not readable to another person. Well, this is where I need to bring in one of my closest friends in the world, Norm Kirchner. So Norm and I have been friends for 15 years now. This is a picture that I think my wife took about a month ago. It was a Friday night, and my wife said, "There's water leaking out of the bottom of the kitchen sink." And so I did a really manly thing, and I picked up the phone and called Norm and asked him to come over. And Norm came over and he helped me fix the kitchen sink, and this is a picture of us trying to fix it. So Norm and I are very good friends. But when it comes to LabVIEW, Norm and I argue a lot. A lot. A lot. So I was putting together the skeleton of this presentation months ago, and I had a few ideas put together. And anytime I run one of my LabVIEW ideas by Norm, he thinks it's a bad idea. For some reason, I thought this time it was going to be different. So I ran an idea by Norm, and I said, "Hey, Norm, I'm going to give this presentation, and I'm going to show some of this code that's readable." And Norm says, "That code's not readable. That code's noisy and distracting. Look at those wire bins. I can't focus on what your code's doing because you've got all those wire bins there." And I was like, well, crap. I've already told GDevCon I'm going to give a presentation on readability, and now Norm's telling me my idea is terrible. Norm, I think it's readable. Norm thinks it's noisy and distracting. I need to seek some wisdom. So I looked for inspiration from Dr. T, founder of NI, CEO for over 40 years. Dr. T had lots of phrases he liked to say, like Brian mentioned one earlier. Dr. T used to say we should take the OOCH approach to solving problems. He had the 100-year plan for NI that he would talk about. He talked about NI being a great place to work for its employees, crazy ideas like that. Well, one of the things that Dr. T always talked about was the genius of the and. That was one of his phrases, where if you've got a couple of things, maybe they're competing ideas, maybe they're not exactly in line with one another. Maybe you can sort of figure out the genius in which those two things can work together. So I said, well, if DNAT says that code is readable and Norm says that code is noisy and distracting, then maybe if we combine them, we've got DNARM saying that the code is readable, noisy, and distracting. And I thought about that, and I thought, you know what? I think that's true. That's perfectly readable code. I can tell exactly what it's doing, but all those wire bins and everything make it kind of distracting. So where does that leave us? What am I going to talk about for the next 40 minutes? We need to maximize readability while minimizing distraction, is what we need to do. This diagram has 0 distractions. Again, it's so pretty to LabVIEW programmers to look at a diagram like that. But the readability is mediocre, because I can't really tell what's going on with those class wires. This diagram has a few minor distractions, some wire bins, but it's got the maximum readability. I can definitely tell how those method VIs are working with that class. So if we're trying to maximize readability, we got to go with the bottom one, all right? So there might be some distractions in the code that we've made that's readable, but we have maximized the readability. If you do find this noisy and distracting, don't worry, this is the last time you'll see this diagram for the whole presentation. We're going to move on to some other stuff. Okay, so how do we write readable code? Every single diagram you write. I think I've given similar guidance like this in other presentations, like my error presentation. I talk about how every diagram you write, make sure you understand the error propagation. Well, with every single diagram you write, is there something I can do to make this more readable? Put another way, always be readable. Okay, I need to workshop this a little bit, but always be figuring out how to make your diagrams more readable, which I think always be readabling sounds better. Okay, we are almost 10 minutes in, and we've gotten to the outline of the presentation, all right? So this is the part of the presentation where I'm going to get prescriptive and suggest ways that we can modify how we write LabVIEW code to be more readable. And I've identified 3 main areas. The way we name objects, the way we utilize text, and the way we craft our block diagrams. These are the 3 areas that I'm going to be talking about today that we can take some measured changes in the way that we normally work to increase the readability of our code. So I've got a couple of disclaimers. The first one is most of the content in this presentation is best applicable if your whole LabVIEW development team uses the same written language. I'm going to be talking about the use of text and language a lot. If you've got some developers that speak English and some that don't, and they're working together, some of the things that I say in this presentation may not apply. Hopefully that's not going to be the case too much. That pie chart that I have up there shows the current install base of LabVIEW by language across the world. 75% of LabVIEW installs across the world are LabVIEW for English. 20% are LabVIEW for simplified Chinese. And all the rest of the languages are those other small parts of the pie chart. So I'm hoping this is a safe assumption that most dev teams are all using the same language when they're writing, same written language when they're writing LabVIEW code. The second disclaimer is a little bit more minor. I'm going to be talking about the use of color to aid in readability. If you've got team members that are colorblind, some of this stuff may not apply as well. So that's something to keep in mind. There's a huge fire hose of stuff coming in, you guys. I've got 76 slides. Is that the last? 78 slides to go through. So again, you may try to write all this stuff down. You may miss something. You can just go download the slides and go back through them later if you'd like to. And then another thing. I'm going to say some things in this presentation that a lot of you are probably going to have a visceral negative reaction to. Like in terms of your best practices in LabVIEW, the way you've always done things, the way people have told you things should go, the way LabVIEW experts have suggested things should go, the way I have probably suggested things in the past should go. And I'm going to say something, you're going to be like, this guy is a fool. Okay, don't try to temper those reactions and maybe just think, okay, is there any validity to what he's saying? You might decide that there's not, but I just want to say, I predict you might have some visceral reactions to some of the things I'm going to say. That's true, yes. There are 78 slides. I don't expect everybody to agree with every one of them. So let's get into the first area, naming objects. So let's start off with a simple one. We shouldn't really be using captions. If you look at the control on the front panel there, its label is actually Apple, but someone has changed its caption to orange. And whenever captions are used on front panel controls, that really harms your readability in terms of making that mapping between the front panel and the block diagram. Believe it or not, I've actually seen people do this with cluster elements, which is a terrible idea. I've got a cluster on the front panel, and I see the names of the things, and then I go to an unbundle by name, and it's completely different names. I have seen this in code. I've seen this in code recently. So try not to use captions if you don't have to. I've also heard people make the argument, well, you know, I've got this thing on the front panel, and I really need to give it a long description on the front panel, but I'll just use a caption for that. That way I can give it a really short label on the block diagram so it takes up much less space on the block diagram. Remember what I said a few slides ago? We're trying to maximize readability. We're not trying to maximize horizontal density. So for maximizing readability, the name on the block diagram should match the name on the panel. Now, there are some legitimate use cases for captions. I've seen plenty of UIs where there's objects on the front panel, and as the code is running, we need to programmatically change the names of those things for whatever reason for the user of our front panel. And in those cases, captions make sense. But for you as the developer, if that code is left in the state where whatever the last caption you assign to it on the front panel, that's what you see, that can hinder the readability when you're working with the block diagram. So if you write some code that looks like this whenever you're modifying the captions programmatically, this will just set them all back to match the labels when the code is done running. Just a little tip to help with your developer experience when you're working with code that has legitimate reasons to change captions. All right, so let's talk about splitters and panes. I develop resizable UIs in LabVIEW. Hunter's given a great presentation on UI stuff where he's talked about the use of splitters to make UIs really easy to resize. But there's a big problem when you use splitters. And that problem, let's compare dropping a splitter on the front panel to dropping literally any other control in the front panel. Let's say you drop a numeric on the front panel. Control space, NC, click on the front panel. The very first thing you're presented with is the name of the numeric is highlighted so you can type in a new name for it. That is not the case with splitters. There's no label that is shown to you for you to immediately type a name. And so what ends up happening is you create a front panel that's just got splitter, splitter 2, splitter 3, splitter 4. And when those splitters are created, you've got pane, pane 2, pane 3, pane 4. And then now you're trying to program that UI, and you're trying to understand how your block diagram is working on that UI, and you see some code that has a property node wired to a pane 5 control reference. What does that tell you? Oh, this invoke node over here, this is working on splitter 4. That doesn't help you at all. So to solve this, there's a really cool tool that you can download on VIPM. It's called Pane Relief. It was written by a developer named Hope Harrison. And when you use Pane Relief, you might know her, when you use Pane Relief, you get this cool UI on the front panel, and you can click, like a floating window sort of, and it sort of draws your front panel for you, all the panes and all the splitters. You can click on one, and you can change properties about it. And the first thing you're going to do is change its name. So this is a really nifty tool, and when you use this tool, you end up getting a block diagram that looks like what's on the left. So all the splitters have a great name. All the panes have a great name. Way better than splitter, splitter 2, splitter 3, splitter 4. Now there is kind of a problem, which is the fact that LabVIEW does not enforce a matching on the label of a thing on the front panel and the label of a control reference on the block diagram. So if you're going to use Pane Relief, you need to make sure to use it before you start creating references. And while we're here, just as an aside, please go kudo this idea on the LabVIEW Idea Exchange. I've been trying to talk to LabVIEW R&D about doing some more investment into the Idea Exchange, so hopefully we'll see some of that. This is an idea that I posted almost 5 years ago to prevent that rather silly scenario of changing the names of control references and property nodes to not match the name of the thing that they are referencing. It's silly that the editor lets you do that, but it does. I don't think it should. This would solve the issue I described on the previous slide, where the splitter name would always match the splitter reference names on the block diagram. All right, let's talk about LabVIEW class properties, one of my favorite topics. So this is something I covered in my ludicrous LabVIEW presentation a couple years ago. I strongly believe, and I have yet to have anybody even come close to convincing me otherwise, that class properties are more readable on the block diagram than method VIs for modifying, the data member values of a class. I have often said that you should use class property VIs to just bundle and unbundle things. That's all you should do. I've often suggested that. I've put that into practice myself, except for the times where I didn't. So there are times where you need a class property VI to do some extra work. And it's a VI, so it can do the extra work, right? Well, what that ends up giving you is code that looks like this. We've got property nodes that are writing values. We've got property nodes that are reading values. And if we look at that first node, there are 5 property writes, 4 of which are just doing a bundle, 1 of which is doing a bundle and another bundle inside of its accessor VI. And then over here on these property reads, we've got 6 reads. 5 of them are just doing an unbundle. 1 of them is doing a whole bunch of other stuff. There is no way that we as LabVIEW programmers can look at this block diagram and know what's going on behind the scenes. Now, if you're just using this API, you don't care. You don't need to care. You don't need to care that when you write one of those properties, some other stuff is going on under the hood, because whoever wrote those property VIs did that for a reason. If you're debugging this API, you absolutely do care which of those property nodes are doing something other than just a bundle or an unbundle. I can't tell. You know what that means I'm doing? 11 times I'm right-clicking on those things and choosing Open Accessor VI and looking at the block diagram to see, does this really just bundle? Does this really just unbundle? Until I find the ones that don't. Or sometimes I don't find any that don't, and now I got to go debug elsewhere. So in this presentation, I've got a couple of what I'm calling experimental ideas, things that I've started doing recently that I'm suggesting maybe other people try and see what they think, and this is one of them. I've started sticking a plus sign on the property folder name for any of my property reads or writes that are doing something extra. I'm not claiming that this is a perfect solution. I am claiming that it's a very easy solution. You literally add a character to a folder in the project, and that's it. You don't have to do anything else. And this lets me, as the user of this API, I'm still seeing the names of the things I want to read and write. As the debugger of this API, I can immediately see which of those property reads and writes I'm going to want to right-click and look on their accessor VI diagrams if I need to investigate something and know that this is doing something more than just a bundle or an unbundle. Maybe you hate the idea, maybe you love it. I'm tending to like the idea, so I figured I'd mention it as something to possibly try. No, I don't got time for a VI analyzer test, Fabiola. I got 78 slides to go through. All right, so next step. I talked about naming things. Now we're going to talk about how to utilize text to improve the readability of our LabVIEW code. So first I want to talk about the context help window. It's a great tool. With the press of a key, you can hover over any object on the block diagram and learn more about how it works. You know what else it is? It's a crutch. If you're using the context help window, that means you need help. It's in the name of the tool. You're looking at a block diagram, you're reading the block diagram, you don't understand something, you bring up context help. If you're using the context help window, it's because that block diagram is not sufficiently conveying to you how it works. If I could look at that block diagram and know how that node worked or what that node does or what that node even is, I wouldn't need to bring up the context help window. So if I press Control-H, it's because there is a readability issue on the block diagram. Now maybe I guess one exception could be, this is code I've never seen before. There's some math functions or analysis functions on the block diagram. I need to kind of learn what they are. I've never even seen them in the palettes or quick draw before. But in general, I've found that when I bring up context help, it's because I'm like, wait, what is that? Or why are they? It's a readability issue. I sometimes do use context help to try to figure out how a node works, but if I have to bring up context help window to figure out like what a thing is, that I should already know what that thing is, then I would say that is a readability issue. And I'm going to get into details more on this a little bit, so don't throw me under the bus yet. I think that the parts of the block diagram that we control as LabVIEW programmers, those are the ones that we should be able to minimize the need to use context help when those functions and VIs are being used. So just to dig into this a little bit deeper, LabVIEW is a graphical programming language. As a result, we use a lot of symbols on our block diagrams, on our functions, on our VIs to sort of describe what's going on. And there are some places where obviously you have to. The add function, the multiply function, you're going to use mathematical symbols. But we use other symbols all over the place, and sometimes we don't use them very consistently. For example, the array functions have the little grid symbol that means an array, but array to cluster doesn't use that, it uses brackets. But brackets also mean round. So brackets are being used for a bunch of different things. What about exclamation marks? Exclamation marks can be the notifier functions. It could be the occurrence functions. It could be high resolution polling weight, which has a little red exclamation mark on it. So we've got these symbols, but they can mean a lot of different things. Well, the thing is, in our graphical language, we also really like to use words and letters in addition to these symbols. If you're working with clusters, you're using the names of the elements in the cluster to figure out what to do. All the property nodes and invoke nodes in VI Server, those are text, those are names. We use, every single TDMS function has the letters TDMS on the top of it. So in our graphical language, we use a lot of symbols, we use a lot of letters, we use a lot of words. And sometimes people have sort of a negative reaction to the idea that there's a lot of words on our block diagrams or a lot of letters. But you know what? I think that it's a good thing that we have letters and words on our block diagram, because take something like the FFT spectrum VI. We've got a little picture of a spectrum. We've also got the letters FFT. Our graphical language is using letters to describe something. I think that's way better than a picture of Fourier with a spectrum on his head. I would much rather see FFT and then try to remember, oh wait, that's Fourier, oh wait, what does Chebyshev look like? He has longer hair, right? And then, wait, Blackman, Hanning and Hamming, their names are almost the same, but they look completely, we can just use the words, right? We can just use the names. We have so many options. We could have a completely graphical icon, you know, little glasses for read, little thermometer for temperature. We could have a completely text-based icon, read, temp. We could be somewhere in between. We could have the word read and the thermometer. We could have glasses and the word temp. It's time now for us to play everybody's favorite game. How many people can I offend with one slide? All right, here we go. Here we go. These sub-VI icons are more readable than these function icons, okay? All right, I guess I didn't offend as many people as I thought I would. The number of times I'm looking at array processing code, and I'm like, okay, well, let's bring up the context help window and hover over it to figure out which one it is. And then if I don't want to bring up the context help window, it almost feels like I need to have like a degree in art to kind of understand what's going on. So today, class, we're going to discuss this icon right here. So we've clearly got that grid there, which probably means array. And, well, there's another grid on the output side, and that one's a little bit smaller than that first one. So maybe this is taking a subset of this array. But, oh, wait a minute. There's also a square there that probably means we got rid of something. So this must be delete from array. Or it says delete from array. Instead of showing the label, I will show the next slide where I show the label. So yeah, we can't change the way built-in functions in LabVIEW are drawn. I'm not suggesting that we should. But there are a lot of times for readability purposes where some of these APIs where there's a lot of icons that look similar. I also think about some of the more advanced functions like in the notifier API. There's like, you know, you stick a thing on the front queue, stick a thing on the front of the queue, pull a thing out of the back of the queue. You gotta kind of study it and see which way the arrows are going. You could just use a small label to describe that function. In my opinion, this improves the developer experience to be able to very quickly see, oh, that's an insert, as opposed to having to Control-H, hover over it, that's an insert. That's for built-in functions. Now, we're writing a bunch of VIs, right? So we have control over the readability of the VIs that we write. And I strongly suggest taking this approach. And again, hopefully this isn't too offensive. I love text-based banners on my libraries and on my classes. You know what array means? It means array. If you take you start trying to be clever with your glyphs and whatever, you start using that thing, hey, is that an array? Is it a matrix? Wait, it kind of looks like a window. It also looks like what my kid would draw as a building. Just use the word. And then once you've got that text-based banner to relate a group of functions, you can use control space, type something, control K to give your VI a text-based icon. If y'all are not familiar with that quick drop plugin, it has changed my life in the past couple of years. I almost never go into the icon editor anymore. Aaron, I'm not going to have time for questions. You got to ask me later. I almost never use the icon editor anymore. I control space, type in word space, word space, word, basically 3 lines worth of text, and then I get a text-based icon. All that to say, I will be showing the icon editor later. But yeah, so this is my recommendation for maximizing the readability of the VIs that you write, which goes against some of the guidance we receive over the years about graphical language needs graphical icons, right? I find text-based icons for my VIs to be much more readable. Now, sometimes I write skinny VIs. You guys like skinny VIs? The ones that are a little short, you can fit a little space in there. Hunter likes them. He knows what I'm talking about. It's hard to fit a lot of text in a skinny VI icon. The example is the one shown here on the diagram where I want to stop the loop based on the Boolean or if a timeout occurs. Stop loop or if timeout. That's already too many words to fit in a skinny VI, right? So I tried to go with a graphical icon with the stop or the time. I'm kind of hoping that conveys sufficiently what that VI is doing. But that was mainly a space issue. Now, there are plenty of times where I write skinny VIs and I just go with text. The one on the left is turning a Boolean to red or green, so I use the TF for the Boolean. The one down here, I didn't even bother coerce voltage. I mean, that fit, so that works. And then the ones up here, I just use the color of the skinny VI to sort of describe what they're doing. They're setting the indicator background to gray or green or red. So those are cases where I just use text anyway for the skinny VIs. But sometimes I find for the skinny VIs, I like to use some graphics. All right, so moving on to crafting your block diagrams. So let's talk about several different areas of crafting diagrams. These are the kinds of things where we tend to throw code together and not think about the readability. This goes back to the always be readabling. Got to come up with some better. So I'm going to talk about some of those small things that if we just spend a few more seconds on, we can improve our readability. And the first is numeric constants. If you drop a double constant or an I32 from palettes, quick drop, whatever, those are your default data types for numerics in LabVIEW. If I see a blue number constant, I'm going to assume it's an I32. If I see an orange number constant, I'm going to assume that it's a double. Don't make me regret making that assumption with your numeric constants when you drop something that's not one of those. Show a label. Label your numeric constants when they are not the default types. If it's an I32, you don't need to label it because everybody assumes it's an I32. If it's a U8, definitely label it because I'm going to assume it's an I32 unless you're telling me otherwise. And then I have worked with multiple instrument drivers and stuff, so I deal a lot with hex numeric values, get the bytes back, check the bytes against the whatever. And when I work with those, I really like to show the extra digits to sort of make it clear to me that I'm dealing with a U8 or a U32. There's a lot of properties you got to set to make those look that way. You got to show the leading zeros. You got to show how many digits that you want to do. There is a plugin on VIPM called Quick Format, written by Tim Robinson. And it handles all of that for you. You click on a numeric, control space, control whatever, forget what he used. And it basically does all of that stuff to it automatically. And it also works on numerics on the front panel as well. So I highly recommend using that tool. Otherwise, it's like 6 steps to bring up the properties and change to the data type and the leading, add space to the beginning and make the leading space zeros. His plugin just handles all that for you. All right, somebody from the audience, tell me what the value of that string constant is. Shout it out. Tab. Tab is the first thing I heard. That's incorrect. That actually holds 2 spaces. All right, somebody tell me, what's the value of this string constant? It's not 2 spaces. That was the first thing I heard. It's actually 4 characters. It's a slash and an S and a slash and an S. Now, the funny thing is no matter what y'all said, I would have said the other thing because this isn't readable. This is a constant I have to guess on what's inside of it. So I have some general guidelines for you for how to have readable string constants in your code. The first is, if you have an empty string, please use the empty string constant, fixed constant. Always use that thing. If you have a string constant with human readable text in it, it's okay to leave alone. Type the human readable text in it, you're good to go. For all other string constants in your code, I want you to show visible items display style. And I want you to set it to the one that makes the most sense. Okay, and that's usually slash codes. So if you've got, for example, a format string, there's going to be some spaces in there probably. There's probably going to be like a line feed in there. I don't know what those are without setting it to slash code values. If you've got just white space in your string constant, make sure you've set it to slash code values. Also, when working with hardware serial devices, I've seen that the hex setting makes a lot of sense on those string constants. Whatever you do, if it's not human readable and it's not an empty string, you should be showing that that display style so that we all know what we're dealing with when we look. So I can't ask you the trick questions. You know, you'll always have an answer because you've got those visible display styles on the strings. Tim Robinson's quick format plugin that I mentioned in the previous slide also works on string constants. So it's really handy to be able to set very quickly, you type an X or you type a slash, control whatever, and it'll set the formatting for you. All right, let's talk about readable path constants. Several years ago, LabVIEW R&D added the feature to paths to truncate them to show you the ... in the middle. I freaking hate that because I've got a path now that I know is on my C drive and I know the VI file name and I don't know anything else. So here's what you do. You show the whole path. And it doesn't have to go off the side of the screen and into the street next door. Just make it multi-line. Just drag it around so that it's not this gigantic, massive, long path constant, but it's a multi-line constant. Follow this advice for relative paths too, because we probably use relative path constants in our code more than we do absolute path constants, but it's the same point. All right, another quiz for the audience. I'm about to show 2 cluster constants, and I want y'all to tell me which one of them contains a non-default value. This is going to be some eagle eyes here. All right, which one of those contains a non-default value? Anybody? It's the one with Fourier in it, okay? Got another one. Which of the following cluster constants contains a non-default value? We don't know because somebody has put icon view on those 2 clusters. So for readable cluster constants on your block diagrams, use the icon view if you are defining a data type. Maybe you're unflattening a variant, or maybe you're creating a queue of that data type. Whatever it is, if you just need it for the data type, use the icon view. Otherwise, use the default view so when we look at your block diagram, we can see what the values are being set in there that are not default. All right, readable array constants. How many elements are in that array that I'm showing right there?
417.
Alan is correct, it's 417. Good guess. No, we have no way of knowing how many are in there. If you have an array constant on your block diagram that I'm looking at, it better be empty if it's only showing 1 element. All right? Otherwise, I want to see everything. So grow that array constant, show me that empty one at the end. The 7 days of the week, I want to see 8 things. I want to know that that's only the 7 days of the week. I want to know that you didn't stick, I can't think of a fake day right now, but yeah, I want to know you didn't stick anything on the bottom of that. So I want to see, thank you, Friday Day. Matter Day is good too. But there are times where we've got array constants that we can't really reasonably fit on the block diagram that contain them. In those cases, grow it as much as it makes sense and show the scroll bar. I hate the way scroll bars look in Windows 11. It's like a little gray 1 pixel wide thing. Remember big old fat chunky square scroll bars? Those were the best. I miss those. I wish we could get those back somehow. I know I could change my laptop to Windows 7 mode or whatever, but then people think I'm a dinosaur and they already think I'm a dinosaur. So anyway, I hate those scroll bars. But yes, if you have a bunch of array elements, just show the scroll bar so we know, okay, there's some more stuff that I need to scroll here. All right, let's talk about readable class wires. Even though Hunter apparently didn't believe me, I have never, ever made a class that used the default red color. I always change the color because that is an unreadable diagram. That is a diagram that tells me that there are 3 classes on it, and that's all I know, and I need to know way more. So change the colors of your classes. My personal preference is I like the chain wire pattern. I don't use other patterns. Other people do, that's fine. I really like the chain. But I've worked on a lot of dev teams where we're working, I've got multiple engineers I'm working with, and I'll be asked a question like, how do I set the UDP poll rate? And I'll say, oh, that's a method on the blue wire. I just say the blue wire. Like, it's the vernacular, how do I know which one of the packet parsers is being used in the code? Oh, that's the orange wire. Like, when you've got these identifiable wire colors that you've set as the author of your classes, it's really going to improve the readability and the communication with your team to be able to very quickly identify what's going on with certain classes on your block diagram. I also really like to go a step further and make sure that my wire color matches my banner color. That way, if I see a string of class VIs and one of them's different, I know that that's calling a parent method, and that's useful to me as trying to read and understand the block diagram. When it's a string of blue VIs and then one yellow one, that's a clue to me of how that block diagram is working. Less stuff that I have to do with the context help window and browsing the class hierarchy in the project. I can instantly read those things on the block diagram. Something else to keep in mind. All right, so let's talk about error wires. I've given a whole presentation on this before, but I'm going to cover a few ideas briefly related to error wires and readability. If you are writing a VI and that VI can generate an error, then I expect that it's going to have an error output terminal, right? So I'm looking at your VIs, I'm seeing a string of them, I'm seeing error terminals go through them. My assumption as I'm trying to read and understand that block diagram is that any of those VIs could generate an error. If a VI cannot generate an error, it should not have error terminals. I'm not going to argue about this because it's semantically true. But as LabVIEW programmers, there's a lot of times we need things to happen in a certain order, right? And the LabVIEW editor gives us the flat sequence structure, but we don't like to use that. We like to use error wires to serialize things. That's just how LabVIEW programmers like to do things. There were conversations within LabVIEW R&D over, in the past where there was kind of a, why do LabVIEW programmers do this? Should we stop encouraging, error wire for serialization? Clearly, those conversations never went anywhere because we all still use the error wire for serialization, right? So, but the problem is now I've got these VIs that I'm serializing with the error wire. Some of them may be able to generate errors. Some of them maybe not. We're going to move on to my next experimental idea, which I guarantee some of you guys are going to go, ugh, when you see it. But just again, try to, prepare yourself. I had this idea that I've been trying. Oh, man. Oh, geez. Okay. All right. Where's the closest exit door? There's one. Okay. So, yeah, I just heard somebody say make it short. But no, the point is that we have to have the error go in and the error come out. That VI might need a bunch of things on its connector pane. We're currently writing VIs that look like these. I'm saying I want something visual on the block diagram to indicate to me that the error wire is being just used for serialization. This is an idea I had. I've been trying out a little bit. Mixed reactions, apparently. So if y'all have some better ideas, and again, I think it's just y'all's visceral reaction. I got a thumbs up from York. Really, that's all I need. That's all I need. That's all I need. Okay. Whew. Whew. Okay. All right. Feels so much better. Thank you. All right. So anyway, if you've got your own ideas about how to signify to me that I'm reading your diagram, and the only purpose of that error wire is serialization, do that. Let me know. Maybe we can come up with something better. Now, next, reference wires. Now, all that stuff I said before about class wires and branching and in and out, that's assuming that we're talking about classes that are being passed by value. The class wire has a value that can be modified, LabVIEW data flow, yada, yada, yada. We also have reference wires in LabVIEW, and we have people that use classes like reference wires. And those guys are perfectly fine to pass through. We love the railroad track with those. The reference isn't being changed. It's just for convenience, purely. So we've got code that looks like that, where we've just got the reference wires just being tracked through. The problem is that all of the reference wires look the same. Library wire, VI, project, ActiveX, .NET, test stand semiconductor module, database toolkit. All of those wires are that green, skinny reference wire. And I have worked on code before where somebody had a VI in and a library out on the same spot on the connector pane, and it looks like it's VI in and VI out, but it's not. So that is not a readable diagram. So the fact that those colors are different is very inconvenient. As LabVIEW programmers, we should be making sure that we follow these two guidelines. If it's the same reference, same spot on the connector pane, 100% of the time. If it is a different object or a different reference or a different whatever, different spot on the connector pane, 100% of the time. I do not want to see VI in and my favorite control out at the same spot. I want to see VI in and either no VI out or VI out and then the control on another spot. All right, so there's a very popular pattern in LabVIEW programming. It's pretty, but we need to stop doing it. And it's this one. Bundling a bunch of control references into the cluster that's being passed around in the code, all right? Sadly, some of the NI templates do this, some of the NI templates that I wrote many years ago. Now, it is appealing, right? Because it's pretty. There's all these things. Look, they're all lined up. Somebody aligned those things. The wires are straight. There's no bends. We've got this bundle. It's so pretty. But it's a terrible pattern for readability. I got this VI here. It's in a frame of my state machine called copy graph. I assume that sub-VI is copying a graph. I see a picture of what looks like a clipboard on its icon, so maybe that's what it's doing. I'm not sure. But it's taking in that whole cluster of references. Is it doing anything else besides modifying the graph? I have no idea. It's taking in the entire cluster. Okay, so let's do that. That's a little better, right? Now we're no longer taking in the whole cluster. We're just taking in that graph reference. But this is still not that great, because when it comes time to debug this code, because something isn't working right with your graph, are you doing a text search for the words graph ref to find all the places where that graph reference is being unbundled? That's annoying. What if there's other stuff called graph ref? There's still this disconnect between the actual object on the front panel and what the sub-VI is doing. So this is what we should do. First of all, I changed the icon to text, and it says copy graph to clipboard, so that's pretty freaking obvious what it's doing now. But look, I'm using a control reference. Now when it comes time in my code to see, wait, where's my graph getting messed up? I search for control references to that graph, and I find exactly where that control reference is being used. We also can tell that that sub-VI is not messing with anything else because we didn't wire in the whole cluster into it. And as I mentioned, it's much easier to find whenever we are debugging our code. Now, there's still a pink cluster wire being passed across in that code, right? We have wisely chosen, based on what Darren has to say today, to no longer include our control references in that cluster, but there's probably some other stuff in that cluster. Maybe there's a few things in it, DQMH code, actor framework code that's well designed. There's going to be a few pieces of data that a given actor or a given module is taken care of. There's a lot of state machines out there, you guys, that have a bunch of stuff in that cluster, a bunch of state data, all the stuff that could possibly work with this application. It's not just a cluster, it's a mother cluster, all right? Now, here we have a VI that's taking the mother cluster in, and it's sending out the mother cluster. And that VI could be doing mother clustering anything. And like, seriously, look at that icon. Somebody professionally developed that icon. It's got a star, which probably means new. It's got a 1001, which probably means binary. I don't know what the heck the thing is on the bottom that the arrow is pointing to. I don't know what that VI is doing. And I don't know what of my data it's doing it to. Now, this is not an indictment of mother clusters. I will be completely honest. I've seen some successful LabVIEW programs that utilize mother clusters. I am not here, I don't personally use them. I'm more of a LabVIEW class kind of guy myself. But I'm not here today to disparage the user of the mother cluster. You might be a mother cluster lover, okay? And if you are a mother cluster lover, you need to be following this pattern. Do not pass your mother cluster into your VIs. Use the in-place element structure to pull out exactly the things that your VI needs to work with. Also see I gave the VI a text-based icon that says process new data, so now we know what it actually does. But yeah, I'm not saying we shouldn't use, I mean, I don't use mother clusters, but some people do, but definitely follow this pattern. Do not pass the mother cluster in and out of a VI, because at that point, you don't know what that VI is going to be doing with it. Again, we're improving readability with our code. All right, so I described all that stuff. Okay, a quick word about labels. All of the VIs in this presentation so far have been VIs that I wrote, and this is an example of one. This is a VI that is reading the device state, and once the device is not enabled anymore, we stop the loop, or if a timeout occurs, okay? Now, I could have added a free label. Read the device state and wait until the device is no longer enabled or a timeout occurs. It's time to play everybody's second favorite game. Can I possibly offend more people?
Yes.
Free labels should not be used to generally describe the behavior of a block diagram. The behavior of a block diagram should be described by the block diagram. More specifically, the readable block diagram, okay? Now, this is a diagram that I wrote. This is doing some, this was part of a driver that I wrote. And the name of this VI is command response. So if you see that name of that VI, and you see a couple of VISA functions on this block diagram, in terms of readability, it's pretty obvious what this VI is doing. I don't think I need a free label to tell you that this VI is performing command response on the VISA instrument, because the name of the VI and the context of the block diagram illustrate that. Now, but you do see that there are some free labels on this block diagram. I've got one that's a bookmark for me to add unit tests. So, you know, when you do code reviews and stuff like that, free labels are good, especially with bookmarks. I love bookmarks for code reviews, they're great. Another place where I'm using a free label is that there is some non-obvious code and logic on the block diagram. I sort of need to explain what it is. You know, what is this response we're expecting from the device? Well, let me just describe the bytes that I'm expecting to get back. Often I will borrow code from places, usually ni.com. When you guys borrow code, please include a link to the page where you borrowed it from. I mean, it's there to be borrowed, right? Somebody posted a VI on ni.com so you could use it. So let us know where you got it from in case we need to go like read a discussion about how it works or whatever. And then this isn't a free label, but it's an object label. I'm pretty, I do this quite a bit where, you know, a constant on a block diagram, if it's not immediately obvious, like if I had just left that 6 there and you're reading that block diagram, you may be wondering, why is it 6? Is that just a random thing he picked? Like with this label, I clearly say, oh, well, I'm always expecting 6 bytes in my response, so that's why that's there. All right. Good timing. Time to summarize. Hopefully I've convinced you guys that it is incredibly important to maximize readability. If nothing else, the fact that I had a rigged question about those string constants lets you know that there are things that are literally impossible to understand on the diagram without making some changes to improve readabilities. The way we name things is one of the easiest ways that we can improve readability. You know, reducing the use of captions, taking the time to name those splitters and panes, giving good names to our class accessors, perhaps experimentally using my little plus sign idea. I strongly believe that text is one of the keys to understanding how a LabVIEW block diagram works. And so being able to utilize that as effectively as possible to communicate how the VI behaves, less time that we have to spend digging into sub-VIs, showing context help, things like that. And then the way that you can structure block diagrams, you know, make those changes like the constant formatting, and which I spent a lot of time talking about, but I think illustrates effectively like little things that you can do on your block diagrams to improve your readability. Don't be afraid to question best practices. You know, LabVIEW is a graphical language. Let's use icons as much as we can to describe the behavior. That's some pretty common messaging that we've had on LabVIEW for a long time. I don't think it's good messaging. I think that there's a lot of times where text can improve readability on a block diagram, and we should explore that and experiment with that, and sometimes get booed when we make suggestions about things like that. The fact that I'm really harping on the text thing is just because, and again, this kind of goes back to what I said before about your development team and the written language that you use. You know, hopefully everybody's using the same written language. We're at a North American conference, so I sort of assumed English would be a given. But when that, you know, the beauty of LabVIEW is not the fact that everything's an icon. The beauty of LabVIEW is how quickly our brains as engineers can put together a diagram using data flow. That's the beauty of LabVIEW. And if, in putting that block diagram together with data flow, we've been able to do it more quickly and efficiently by utilizing text, then why not just do that? All right, everybody, we need to remember, always be readabling. If anybody has a better idea for that slogan, let me know, because it's kind of under construction. I am right at time. Thank you very much, everybody.